Yo, it's Jonathan. Today we're gonna be learning properties of exponents. In this video, you're gonna be learning about the product rule and the quotient rule. Specifically, we're gonna be looking at these two examples right here. And one of the important things to understand that when you are doing product rule and quotient rule, whenever you're doing product rule, you're gonna be using addition, and whenever you're using quotient rule, you're gonna be using subtraction. And I'll explain to you guys what I mean by in this example. So right here on the left, as we can see, what you want to do when you first start off with one of these questions is you want to look at the bases. So the base number here is 2, and the base number here is 19. And then we want to look for common variables. So we see an n here and an n here, and then we see an m here and an m here. So simply all we're going to do is we're going to compute this out. So, but in terms of the exponents, so as you see here, we have n to the fourth power multiplied by n to the second power. So all you're going to do here is you're going to add these two exponents together. So n to the fourth plus n to the second is what? 4 plus 2 is 6. So that's going to be n to the sixth. But first, we have to individually compute each variable out. So this 2 times 19, we're going to have to multiply out. And we know that 2 times 19 is 38. So we'll write 38 over here. So 2 times 19 is 38. And then, like I said, we're going to have to add the exponents. So n to the fourth plus n to the second is n to the sixth. And then we're going to do the same thing we did with the n's with the m's. So m to the third plus m to the ninth is going to be what? 3 plus 9 is m to the 12th. So your answer is going to be 38, n to the 6th, m to the 12th. And as you can see, all we did was we added the exponents together and we computed the rest of the problem. So we're going to do the same thing over here, but like I said, when we're dealing with division, we're actually going to be dealing with subtraction while still doing the actual division of the equation itself. So what we have here is 9 divided by 9. So those cancels out. That just leaves you with a 1 in the front. But when we see a common variable here, x and x, and then a, we're going to subtract from bottom to top. So x squared minus x to the third is actually x to the 2 minus 3 is negative 1. And then we have a to the fifth minus a to the sixth. 5 minus 6 is also negative 1. Okay? But one of the important things to understand here is that whenever we have a negative exponent like we do here, we're going to have to actually rewrite this in a different format. We're actually going to have to write this as a fraction again, but we're going to have to put all the variables with a negative exponent in the denominator. So we're going to have to write this as a fraction. So on the top of the fraction is just going to be 1 because 9 divided by 9 is 1. If it were like, let's say 18 divided by 9, it would just be 2 on the top. And then so we're just going to put x and a on the bottom. So whenever we have a fraction, we know that they have to have a negative exponent, but you no longer have to write that negative exponent in the denominator because being in the denominator implies that it has a negative exponent. And so you can put the ones if you would like, but the ones are actually implied as well. So you can do x to the first power and a to the first power, or you can just leave it as x to the a.